Good morning.
Good morning, it's Duncan.
Good morning, Duncan. How are you doing?
I'm good, how are you?
Very good. Nice to see you, man.
Yeah, good to see you as well. You don't seem to have the traditional Brazilian accent.
No, I do have, yes. You will see with when we start to changing for Spanish, Portuguese, and then English, and
it will come back.
Yes.
Yeah, it's difficult. I mean, switching languages is not easy. Right? Most Americans don't know because they never switch languages. But you know, for us, like for myself as well, and for you, it's not easy.
No, it's not. And when you like when we have the events in Las Vegas or San Francisco, and we stay outside, like we stay out of our country for a long time, then you start to get more tired to think about. So your capacity of talking another language will be decreasing as long as you are outside of your own country.
Yeah, I guess it also depends on who you hang out with. So what I noticed is because a lot of the people that I hang out with are people like Cormac and some of my other colleagues in the US. So we only speak English, which means that at the end of the week, I find that I tend to even start thinking in English, which is weird.
Yes, because you guys are maybe more used to do so. So when we are like in a huge Brazilian community in the United States, sometimes you talk in English, but a lot of times you are talking in your own language.
Yeah,
and
exactly.
Then the switch back is a little bit tired.
So I guess you guys invited a lot of people.
Yes, we do have almost 300 registrants, and right now
it's 70 people already.
We have 68. We have a lot
and I'm guessing they can hear us talk as well, by the way.
Yes, so Cormac.
You need to be careful what you say, Cormac.
Oh yeah, why?
Well, you never know if
caught like that before, right?
Yeah, you never know if HR is listening as well.
Andrioli is right here. And have
if anyone who's listening, by the way, has any particular questions you always wanted to ask any of us, feel free to drop them in the chat window. Right, if you want to know. You want to know something about Cormac's hair, right? What kind of brush he uses, or how I do my hair? I'm happy to.
Yeah, you won't get that question. You won't get that question.
No one wants to know.
What about that guitar? What about that guitar in the back for him? Is it just for show, or he actually plays that?
No, it's just for show.
Okay.
When I grow up, I'm going to be a rock star. When all this VMware virtualization stuff is finished with, I'll become a rock star then.
Yeah, but you are a rock star, man.
Yeah, right.
Good point. Good point.
So we do have a question, by the way, that I want to answer. Someone is asking when the next book will be out, and I'm guessing he's either referring to the vSAN deep dive book or potentially the clustering deep dive book. So the vSAN deep dive book, Cormac and I haven't discussed yet if we're going to update it, and if so, when. But considering there are many changes in the 7.0 release that we'll be talking about in the upcoming hour and a half or so, we will be updating it at some point, but there's also going to be a lot of changes in the next release. So that is something that we'll still need to discuss. The clustering deep dive book is something that Frank and I are actively working on. Hopefully we'll be able to release that at some point this year. It's we were planning on releasing it actually with the 7.0 release, but then we found out that there's going to be some major changes coming up in the upcoming releases. So we decided to postpone the book, because otherwise people would end up, needing to buy the book, twice in 6 months, which doesn't make sense.
Mm-hmm.
You know what?
That's exactly what you want.
Well, from a business perspective, it makes sense. From a community perspective, it doesn't.
You know what I just found here, Duncan? I recall, I don't know what year was that. Probably, I don't know, 2000. I didn't even try, but you might remember this book.
Yes, that's 10 years ago, exactly.
That helped me a lot back in the day, man, with a lot of the deep dives that I was scratching my head that the customer is actually starting to scale with vSphere. There's a lot of good knowledge here. Thank you for that.
Yeah, no problem. Yeah, our pleasure. I mean, for us, one of the reasons as well that we started writing that book in particular was the fact that there was, there wasn't a lot of information around, but also the information was spread in multiple different places, even within VMware, and even within the engineering team. So Frank and I would always find ourselves, talking to the engineers, and one of them would be able to tell you, about this particular aspect of HA, and then the other one knew something about another aspect. There was no single person that understood the whole solution end to end, except, by the way, for the GSS team. So the support team, we had some engineers that actually understands it. They understand the concept end to end, but of course they typically don't have any time to share the knowledge with a broader audience. That's not what they are being paid for. So that's why we decided to end up, writing the book, it was very cool. When Frank and I first discussed it, it was funny because I still recall when I was having the conversation with Frank, and Frank and I were, discussing, how many books do you think we will sell? We're like, no, well, maybe 250. Well, if we're lucky, maybe 500. It's a deep dive. Who's going to read a deep dive? So far, there weren't that many books that, were selling that were real deep dives, actually talking about the algorithms and stuff like that. Yeah, it was slightly more than the 500 that we anticipated, which was amazing.
You thought it was 500. I said it was 80. And so it was even nice. But do you have this one? Shit, it's downstairs. It's the Japanese version.
Ooh. Wow.
Yeah.
Oh, I have that one somewhere here as well. Yeah.
Yeah, nice.
There's an important question in the Q&A, Duncan.
Yes,
which one?
about Arctic monkeys. Is that one? Yes. Do you like Arctic monkeys?
I love the first 2 albums. I think the first 2 albums of the Arctic Monkeys I just happened to listen to it this morning. So those are excellent albums, very energetic, they're just fun to listen to. The last couple of releases, yeah, it's not as exciting as it used to be, unfortunately. It's I don't know what happened with the band, but I still enjoy the first 2 releases. The last couple of releases, I'm not the biggest fan anymore, unfortunately. But the first 2 releases, definitely, it's a great band.
That's great. And Cormac, what do you like to hear?
My most recent acquisition.
What does he got there?
Oh. I don't know, can you even see this? Some Finnish folk metal. So, can you see it at all? I don't know.
Yeah, we can see it.
There we go. It's a firm. Yeah. Yeah, so mostly metal.
And do you like the vinyl ones?
Which ones?
The vinyl.
Yeah, that's what what he was showing. It's a vinyl. It's an LP.
Oh yeah. So, yeah, I think so. I haven't been buying a lot of vinyl, but because bands can't tour because of COVID and everything, I started just buying some stuff online, some vinyl again, try and help them out. So I know that they don't make a lot of money out of Spotify because I usually listen to Spotify pretty much all day long, but they only make pittance out of that. So I've been just buying some vinyl off Amazon and stuff. Yeah. So that's my thing.
Great. And how about Frank? What do you like to hear, Frank?
Oh man, that can be so much. I listen to 90s rap, 80s pop, and 70s soul. So those are the three I listen to the most. So I haven't really got into the 90s and the zeros yet, but if we move away further, well, at one point it becomes interesting again. But yeah, those are the top three. The stuff that those guys listen to, yeah. Oh, Foo Fighters. That's one that I like as well. But other than that, no. The stuff that Cormac listens to, no way.
You mean you're not a Finnish folk metal fan? Come on.
No, there are days that I don't put that on. Yeah. So. Yeah.
Do you know, guys, that we have not we, but we as VMware, we have like the virtual metal community on Discord.
Oh yeah.
Yeah, I've seen it.
It's a big metal community. I don't know if you guys are there, but it's a big one. And they have I think every Thursday, there's a very good meeting out there in which you can be a DJ for one day. And then you can show your playlist, share your playlist with the entire community. It's very good.
Yeah, I've seen it, but I just have not had the opportunity to join it. So there's always it's that time of the day. It's like 4 p.m. and there's always meetings because Palo Alto are coming online, and I just never have the time to join it.
But you know what, Cormac? I actually wonder if us in Brazil, for example, in my case, or in Diego's, and many people in the call here today as well, of course. When we say metal, are we talking about the same bands that we, for example, Cormac, where are you based at? Where are you speaking from today?
Ireland,
right? Duncan, you are in?
The Netherlands.
The Netherlands, right? Frank, what about you, man?
Netherlands.
Netherlands as well, right? So, so we say metal. We know metal is very big, a lot of stuff under that umbrella, right? I mean, what bands are we actually talking about, right? For example, for me, I don't know, let's say...
Sepultura?
Sepultura, of course.
Yes, there you go.
That's the one who went to the shows and all that, right?
There we go, man. There we go.
But let's say from Metallica all the way up to, say, Megadeth and moving on, there's plenty of stuff that got here. But of course, nowadays we have Spotify, internet, and a new band that showed up in countryside Netherlands pops up in Diego's Spotify next week, right? But I wasn't born yesterday. I'm over 40 years already, right? So it wasn't that easy back in the day to find those bands. So it's always a buddy of a buddy, almost like technical knowledge, right? You have a buddy. Yes, we go find stuff online, but it's always a buddy that helps you do stuff, right? I think everybody here can relate to this.
Cassette playlists, right? Your buddies would make cassettes with all playlists of bands. That's how you get into it.
Exactly.
Someone is saying that he prefers to hear us talk about metal instead of VCF.
Yes.
That shouldn't be a problem. I can talk about metal for hours. So
and Marcelo's just mentioned Rammstein. I was supposed to go and see them play in Ireland last month, but of course everything has been cancelled now. So those guys. What?
They haven't toured for a long time.
Rammstein?
When did they start again? Yeah.
Yeah, they were touring. Well, I don't know whether they were doing some special kind of European arena events or those kind of things. But they were supposed to be playing in Belfast in June, and of course with COVID and everything, the whole thing is canned. Yeah.
But for the people from Brazil on the call, when we are talking about Sepultura, are we talking about the early albums? Do you guys listen to anything beyond Roots, Bloody Roots as well? Because that's where I stopped listening to the band.
Beneath the Remains, man.
Yeah, exactly. Well, I like Refuse. I like the first 3 albums, basically. Chaos AD as well. I think that's also a cool album. But after that, it just went down very fast.
Yeah, came the news where they start the decline until that's what most of us here, at least back in the day, were like, well, they're stopping to be the Orgasmatron Sepultura that we liked, etc. So that was back in the day. And by the way, vSphere runs on Metal. So maybe we should tweak that phrase here because we run on Metal. So we get somewhere here, perhaps. By the way, folks, you are all very welcome to Brazil. I'm seeing people from Argentina, Mozambique, who knows where from today here in the call. You're all very welcome to be here with us today.
Oh, I should have worn my Argentina football jacket. But for whatever reason, when I received this, invite, you guys told me not to wear it. I don't know why.
Diego, you still have that disconnect button over there, right?
Yeah, exactly.
Yeah.
Just check.
There you go. We were making
for Duncan.
Yeah, we were making all these friends talking about metal. And he goes and
it's all good.
Even the people from Brazil know that Messi is a brilliant player. We all got to admit that. So
yeah, yes.
I'm not saying that Argentina is the best team, by the way. So don't get me wrong, because I don't think they are far from the best team in the world. Far from, but they do have one of the best players. So
the Netherlands impressed a lot in the last cup, right? I mean, I thought you guys were going to nail that last time.
Yeah,
the previous time.
Yeah, the previous one. Yeah, I'm sorry. Yeah.
Yeah, I mean, we did very well in 2 tournaments, actually, both of the World Cups. And I think everyone first of all, no one expected any of us to win anything. They didn't even expect us to go past the first round. I was just reading a book on the topic, by the way, and basically they said, although we knew we didn't have the best players, we knew we had one of the best teams. I think that was the strength of those 2 tournaments. But unfortunately, we didn't make it. I mean, against Spain, there are still rumors floating around that the whole team of Spain was completely doped up, as in using steroids and what have you. So, and then in the other one, we weren't good enough to win the second one, where we came in third. I think that one was to be expected.
We're the only country in the world who's gone to 3 finals and never won it. So that's a record. That's a sad record.
It is what it is. It's also a tiny country, right? We have less people in our country than most larger countries have in one of the cities. So
maybe Ireland.
One day, Cormac. One day.
Or you could move, Cormac, I mean, we have plenty of space here in Brazil, man. You could move, I mean, we have plenty of space here in Brazil. So
yeah, I've already used up my full Portuguese vocabulary with Bom Dia, so I'm not sure how that will work out.
Someone asked on Twitter if you guys will be presenting in Portuguese or in Portuguese.
That's Dave. There's Dave Moreira, I think.
Dave Moreira, yes.
Sure.
Hey, Diego, what's the hashtag for today on Twitter? What are you using?
I'm not using now. We can come up with a hashtag right now because I'm managing 3 social networks by the same time. You can come up with something.
Never mind. Let's focus on what we're talking here. That's it.
Hashtag Metal VMUG.
I like that.
Someone told that Cristiano Ronaldo is the great of this generation.
I'm not sure. I've seen them. I've seen them both play against each other in Barcelona. So Barcelona against Madrid. I think he's a great player. But if you look at it purely from a football perspective, I think Messi is a better football player in terms of talent. But Ronaldo is just, his work ethics is just insane. The guy doesn't stop running.
Look at the chat window.
Yeah.
He's a 17. Exactly. And it's okay. There's still people using Hyper-V. That's fine. It's just not as good.
Yes.
It's not as stable, as consistent.
Okay, that can easily consume the entire morning. But I'll tell you, as a Brazilian, for me, from all the Brazilians I saw playing, Ronaldinho Gaúcho, that's the god of the ball. That guy could play.
So which team did he play for?
Ronaldinho Gaúcho, he played for, he played in the Netherlands. He plays, was it Ajax or someone else? The one with a gray shirt, a gray jersey they use in the Netherlands. Then they went to Barcelona and then to Milan on their height days. And then, of course, the Brazil team, Ronaldinho Gaúcho, because we had two Ronaldos, right? Ronaldo, we had the last Ronaldo, we called him Ronaldinho. He won the World Cup for us in '96, I think. But Ronaldinho Gaúcho also played a lot. I'll stop here because it's easy to go.
I didn't recognize the last name, but now I know. He's a great football player. He's got excellent skills.
But that was back in the late 90s, right? I think he was at Barcelona like 99, 2000, something like that.
Yeah, no, it was 2003 or 2004, something like that.
After that was drink and booze and party and.
Hey, but that's the problem with a lot of those guys.
down the hill.
What's wrong with that?
Yeah, I see people in the chat talking about the other Ronaldo. We call him Ronaldo the Phenomenon because he was pretty good as well.
Yes, there was a time that we had like two Ronaldos, right?
Yeah, I mean Ronaldo used to play for PSV in Eindhoven, which is where I live next to. It's about 20 kilometers from here, so I think we've seen him many, many times. He's a pretty big boy these days, I guess. As in, he's quite bloated.
Lionel Messi answer. Someone asking about when the meeting will start. So we will start in 10 minutes. Yes, Duncan, I think it's 10 o'clock, right?
Yes, correct.
Yeah, so we have time to go grab a coffee, get a favorite chair, right? It's gonna be relaxed.
Yes. And one another question, guys, going back to the books again, if we can. How do you guys do to write a book together? Like how is the process to write a book with another person? Because writing a book alone is hard, and writing a book in a team I think it can be harder, right?
Yeah, I guess it very much depends on who you work with. I mean, so I've done 4 or 5 different books with different people. The last 2 being with Frank and with Cormac, and I've done books with other people as well. When people are not motivated or not driven at the same level that you are, it becomes very challenging. Fortunately, working with Frank and Cormac has been fairly easy. And the way we've done it usually is we carve up the content in half. So I take chapter 1, Cormac takes chapter 2, I take chapter 3, he takes chapter 4. Sometimes, there's an overlap between 3 and 4, then he would take 3 and 4 and I would take 5 and 6 and what have you. And with Frank and myself, there was a clear separation. So I would do HA, he would do DRS, then I would do stretch clustering and he would do storage DRS or, something to that extent. And when you divide it up that way, it's actually pretty simple because you're individually working on chapters. You run through your chapters, you make sure you have all of the content ready. And then we do peer reviews. So as soon as my work is done, I hand it over to Cormac or to Frank, and then, they read it and provide feedback, and you start going from there. But it very much depends on the person you work with, because I've done it in the past as well with people who would never meet their deadlines, who weren't responsive, they were supposed to write a 50, 60, 70, 80 page chapter. They end up delivering 5 pages while you've just written 150 pages. Yeah, then it becomes almost impossible to work with them. So you need to be able to rely on the person, and it needs to be a person you can get along with and you trust as well. I think getting along with them is fairly important, because you will find yourself on the phone regularly just discussing things, maybe 5-6 times a week. So if you don't get along, it's going to be impossible.
Yeah. So one of the things that is interesting is, when you start writing, it takes a long time, and you need to spend a lot of hours, not just 1 week, many weeks. So forget birthday parties, forget other stuff, because you're writing for like 6-7 months. So a lot of people are in love with the result, having completed the book, but they're not in love with the battle itself. And it is a battle, just grinding it out, and everything what you're writing about, you're going to second guess. You're going to second guess the most simple things that you always assumed were correct. And that's the beauty of, I think, and maybe the other guys can chime in, I think that's one of the most coolest thing of writing a book. You reset everything that you've learned, and you learn a lot of new things along the way. And yeah, but the key is, if you want to write a book, be in love with the battle, not the end result.
Yes, and you guys wrote a lot of books, right? So, and the results are, and one thing I think it's very interesting, as we are talking about, like this is a community presentation, community webinar, is that a lot of the books you ended publishing for free, like the 6.2 essentials, I think. And there was a time on this vSAN 6.7 was free also. I think the 6.7 for vSphere clustering also, there was a time that the book was free also. So you ended up delivering those content for free to the community, right?
Yeah, well, sort of, right? So there's two things. It wasn't really for free, because it was sponsored by Rubrik. So we did receive some form of royalties for those books, but they were capable of distributing an unlimited number. So, relatively speaking, we didn't make a lot of money, and that was, for us, one of the reasons for us, writing the book is not about making money, because if you look at the royalties, the percentage you get from the sales, it's relatively low. If you compare it to the number of hours you have to spend working on writing a book. For us, it was more about, sharing the knowledge, getting the information out there, and helping other people as well. Plus, on top of that, of course, it has a benefit from a career point of view, because you have written a book, people within the company that you normally wouldn't be talking to, now all of a sudden have seen the book, they know your name. Like Cormac and I met Pat Gelsinger in Beijing when we were in China for a book signing, and Pat Gelsinger was there to do a presentation, and he walked out of his presentation, and he saw this long, massive line of people waiting. So he followed the line and ended up in front of the line where we were signing books. So we met up with Pat Gelsinger as a result, right? So that is something cool. And when Frank and I finished our book, we actually went over both to Pat, but as well as to Ray O'Farrell and some of the other C-level people, and we actually handed them a physical copy of the book. So, it's more about getting your name out there and stuff like that, rather than it is about, the royalties that you get from the book, because you won't get rich. You're better off working at the McDonald's, is something that Frank and I would always say to each other.
You do get to meet lots of people, because loads of people ask you, can I have a free copy of the book, please?
Yeah. It's the most common question. So I think we're going to get started in a minute.
Okay. Yeah,
but
that's true.
There's one question about the transition from writing a blog to writing a book, if that helps. For sure. if you've written blogs before, like Cormac and Frank and I have done, as in deep dives, longer articles, you know the amount of time it takes to actually research particular topics, which makes it a lot easier to figure out the schedule for writing a book as well, because you can understand how much time is going to go into it. So that definitely helps. So, you know, if you're planning on writing a book or thinking about writing a book, you start with writing a couple of blogs. So you, first of all, we'll figure out if you actually enjoy doing it, because if you don't enjoy doing it, don't even start doing it. And then secondly, we'll help you figuring out how long it's going to take, what you would like to write about, and what have you. So it's definitely something that I would recommend people to do first.
That's awesome. And we are the real benefited here. So we can read your books and your blogs.
Thanks.
Yes.
Excellent.
So I'm here, late, but I'm here. Hello, everyone.
Hey, Anderson.
Hey.
Hello. So, guys, we want to tell a few words in Portuguese and Spanish for the attendees before we begin. Okay,
Sure.
It's very quick. Pessoal, bom dia. A gente vai começar a apresentação. Obrigado por estarem aqui. Se vocês quiserem fazer qualquer pergunta e quiserem fazer a pergunta em português, façam no chat ou no Q&A. Melhor no Q&A para a gente ter o tracking, tá?
É pergunta só no Q&A, no chat não.
No chat não, tá bom. Então só no Q&A e podem fazer em português, que a gente traduz em inglês, se vocês não quiserem escrever em inglês, tá? Y las personas, hola a todos de Latinoamérica, ¿cómo están todos ahí? ¿Todo bien? Muchas gracias por estar acá con nosotros. Y si tienen preguntas, por favor, hagan en el Q&A. Y si quieren hacerlas en español, se pueden hacer en español y nosotros podemos hacer la traducción para Frank, para Cormac y para Duncan. Muchas gracias. E empezamos, sim, pessoal? Um abraço.
Antes de empezarmos, vou para português e cambiamos para espanhol depois. Vou pedir para o pessoal, bom dia, pessoal, colocar aí em qual região do Brasil você está, qual região da América Latina você está, qual região você está aí no chat para a gente poder saber de onde estão vindo os nossos participantes, né? Então, quem puder colocar aí no chat aí, de que cidade você é. E agora, meu amigo Diego vai falar em espanhol lo mesmo.
Sí, por favor, pueden decirnos dónde vienen, dónde están mirando la presentación, dónde están atendiendo la presentación, porque Mozambique, Colombia, Medellín.
Medellín, Colombia. Buenos
Aires. We have people. We have people from around the Latin America, guys. So
I usually start asking people to put in the chat where they are from, so we can make them more comfortable using the chat and making the questions. So, obrigado a todos, graças a todos. Por isso, agora podemos começar, certo? Now we can start, maybe.
Yeah. So if you guys want to start, we can go ahead.
Okay, let me share my my presentation.
And thank you very much, guys, for your time here today. Okay.
Our pleasure. I'm going to stop the video because I want to make sure that we have enough bandwidth, and I don't want to have some connection issues. Okay.
Okay.
Cool. So hi, my name is Frank Denneman. I'm a chief technologist of the CPBU, and today we're going to talk about a new platform for a new decade. So hold on, my screen is not working. Yes. So why does VMware have so much interest in redesigning all the components that make up the software-defined data center? And according to IDC, which is an analyst company, 70 million applications run in the enterprise data center. And over the next 5 years, 500 million more applications are expected. Now, these apps are mostly developed in-house to directly support the business strategy. And the majority of those applications follow the cloud native structure and typically run in containers. So Kubernetes is used, Kubernetes is used to orchestrate container workloads. And as you can see by the results of this developer survey, they really love it. Kubernetes was released in 2015, and it has consistently ranked as one of the most loved platforms for developers. This survey is done by Stack Overflow, and Stack Overflow always publishes those surveys. So if you're interested, go to their website and search for the annual developer survey. It's really interesting. But what if you don't have a in-house development? 451 Research, that's another analyst company, tracks over more than 200 software vendors. And their research shows that these vendors are moving to containers as a software delivery standard. So there is a chance that you will get new software delivered in a container format. So with these developments in mind, with the amount of new applications coming in a cloud native format, working or running inside of containers, we need to make sure that the SDDC can run those new workloads. And they should run efficiently and they should run securely. And so that means that you have to manage them properly, and of course they have to perform. So we concentrated on this effort actually for a while now. In 2019, we released NSXT, which provides Kubernetes support. CNS, Cloud Native Storage, started with Project Hatchway back in 2017. Knowing that Kubernetes was released in 2015, the cloud guys or the storage guys were really early to the party. And Cormac is going to deliver CNS in great detail. But what is happening with the vSphere platform? So in 2016, we started to re-engineer vSphere. And we defined two major goals. The first goal was to integrate Kubernetes into vSphere, and the second goal was to rewrite DRS so it could handle running and distributing containers. During that project, we asked ourselves the following question: what is a workload, and how will a modern application architecture look like in the near future? So when we started to think about how to integrate Kubernetes into vSphere, we actually broke it down into three separate goals. One of the goals was to integrate Kubernetes into the kernel that allows us to expose a direct interface using those Kubernetes patterns. And the second goal was to introduce what we call a native pod construct, so a pod element, something similar to a virtual machine, but run it inside vSphere to deploy containers, so it's a first-class citizen equal to a virtual machine. And the third goal was to provide a set of capabilities to make Kubernetes run great on top of vSphere. And because these new workloads have a different life cycle than traditional VMs, we need to redesign our own cluster scheduler. And that own cluster scheduler is, of course, DRS. DRS needs to be able to handle the churn of containers. Containers power on and power off much faster and in shorter terms than a virtual machine itself. So if you look at the modern application architecture, you will see that there's the central point is a containerized application, but that containerized application cannot run on thin air. So you need to have a running environment. Typically, this is offered by Kubernetes. Now, Kubernetes itself is an orchestration engine. It uses a runtime such as Docker to actually run the containers, and Kubernetes makes sure that those containers are started on different worker nodes. So the interesting thing is that when people talk about cloud native and cloud native applications, they typically only talk about that. But the reality shows that just running and just building an app inside a container isn't suitable for most enterprises, because you want to connect them to services of your company, of your business, that have been running for many, many years. So what you see is that most containerized applications are actually running and communicating with traditional applications. And typically those traditional applications use databases. Now, these applications and databases, those run in virtual machines. So think, for example, a new online banking service, typically developed in a container, but it uses the accounting service that has been running in the VM for a long, long time, sometimes even decades. So with this mix of containers and VMs, you get an interesting set of challenges. So you have these two personas. You have the IT ops team that can be an admin, or that can be an architect, and you have developers on the other side of the house. So for the developers, these challenges are like, how do I deploy this app, and how can I operate this app for like in day 2 operations? And what type of tools do I use with this? But for the admin, it's all about, okay, so now I have VMs and I have containers. How do I ensure the availability of this app, and how do I make sure that it's secure? Can I give the right quality of service? What do I need to provide from reservations and priority and all that stuff? And how do I control the cost of infrastructure? If I allow a developer to directly use my platform, can I make sure that he or she doesn't overconsume the environment? If they can go nuts and just completely consume the entire cluster. Those things are things that we as a company need to understand and need to work towards to provide a good solution. So what we came up with, and how we're going to solve these challenges, is by introducing 2 separate platforms, but they work closely together. You have vSphere 7 with Kubernetes, now called vSphere 7 with Tanzu, and you have Tanzu Kubernetes Grid, short TKG. Now, vSphere 7 with Kubernetes or with Tanzu allows you to run containers inside vSphere. So a container is something similar as a virtual machine. TKG, on the other hand, is a certified distribution of Kubernetes, a upstream compliant version of Kubernetes. It's developed and it's supported by VMware, and it runs inside VMs, so on top of a vSphere cluster. Now, the Tanzu portfolio is backed by Heptio and Pivotal products and services. Cormac recently published this excellent article that shows and provides an overview of the portfolio. So if you're interested in these things, please check out Cormac's article. It will help you along the way. But let's zoom into vSphere with Kubernetes. If you look at a standard components of a vSphere cluster, you have the ESX host, and they run this service called hostd. Now, hostd is responsible for actually running the virtual machines on the host itself. When you enable vSphere 7 with Kubernetes, the first thing what we do is we're going to deploy a highly available Kubernetes control plane. We are going to deploy 3 virtual machines that run the control plane, and we make sure it's load balanced. Now, the next step is to initiate a spherelet. And the spherelet is our own implementation of the kubelet. And the kubelet acts as an extension of the control plane. The kubelet is actually responsible for starting up containers in a Kubernetes worker node. Now, if you have these components active, combined, they make the vSphere cluster, or they graduate the vSphere cluster into what we call a supervisor cluster. So if somebody refers to a vSphere cluster as a supervisor cluster, that means it's vSphere with Kubernetes enabled to allow you to run containers natively. Now, when a developer wants to deploy the workload, he or she is going to interact with the Kubernetes API server, and it will initiate pods with a CRX, a runtime engine, and that allows Kubernetes to actually start to run containers. So let's take a closer look at the vSphere pod. Now, a pod is a unit that can hold 1 or more containers. And in order to run a container, you need to have an OS. Typically, that's Linux, and a container runtime. One of the most famous one is, of course, Docker. We use our own. We use CRX. You need to have this because the container is not a separate entity such as a virtual machine, but it's a collection of Linux processes and objects. So we encapsulate all these components in this lightweight VM to offer isolation, security, and of course, the performance I mentioned before. We use our own container runtime, and we inject a running Linux Photon OS straight from the ESXi memory into the pod. And that allows us to actually completely circumvent the boot time of a Linux OS. It is incredibly fast if you want to start a pod, and typically a pod is active within 800 milliseconds. Now, one of the things that we also looked at was the footprint of the pod itself. When we say it's a VM, people always think about Linux VMs or Windows VM bloated machines, but this is a stripped down version. And one of the things that we've done is we only use para-virtualized devices. Para-virtualized devices use our own drivers. So we completely control the footprint of this pod itself. Typically, a footprint of a vSphere pod is around 5 megabytes, so really, really small. Now, one of the things what we do is we use the spherelet that runs on the ESX host to control what happens inside the pod. So the spherelet talks to the container engine, and that will finally initiate the controllers that are running the actual application of service inside this pod. Now, one of the challenges of creating pods and running containers and VMs in one platform is to deliver a quality of service to a distributed set of VMs and containers. And what we came up with is the vSphere namespace. This is something we introduced with vSphere 7 with Kubernetes, and it allows the IT ops team to specify the compute resources, the storage policies, and the permissions who can actually interact with that namespace. So that namespace acts as a guardrail. So the developer can deploy straight into that namespace by using an API endpoint and consume the resources of the supervisor cluster without the assistance of the IT ops team. Now, beyond the native integration of containers, we know that a lot of developers want to use a specific version or a fully upstream compliant version of Kubernetes. And for these wishes, we've built a Kubernetes cluster service, allowing the developers to deploy TKG clusters on top of the supervisor cluster. Modern application, like I already mentioned, is typically a hybrid version of containers and VMs together. So we introduced the virtual machine service, and that allows a developer to self-service and deploy virtual machines on the supervisor cluster by using Kubernetes API commands or a YAML file or a deployment. Now, the third thing is, and this is really interesting, is that we've designed the supervisor Kubernetes cluster to become an ecosystem for solutions. By using Kubernetes operators, we can plug in available databases, messaging frameworks, and maybe even AI ML tools. And that turns the vSphere, the supervisor cluster, into a platform for platforms. Now, as I mentioned before, containers have a different life cycle and they introduce a different pattern of churn on the cluster. So we had to do something about DRS as well. Now, DRS was introduced in 2006. That is 1 year before the iPhone 1 was introduced. So think about how life in the data center was then back then, right? It was different. We looked at virtualization for cost savings, for increase of efficiency, how many workloads can I run on a bare metal server, and we started to consolidate particular active workloads. Now today it's different. We focus on VMs and containers, and we look at new types of hardware. Think about vGPUs, FPGAs. There are all these type of new workloads, ML, AI, that needs to be catered as well. So one of the things that these new hardware does is they introduce these different levels of memory and compute. And another thing is that the cloud native workloads, they create shorter life cycles. Now, what we've seen at big cloud companies such as Amazon, Google, and Microsoft, these containers, they spin up and they shut down sometimes in days or sometimes in hours or even minutes. We expect in an enterprise that containers will run for a few days, but think about how VMs run. Typically you enable a VM, you deploy a VM and you shut it down when the next service maintenance occurs, or maybe you don't even shut it down and after 3 years you replace it with something new. So this churn needs to be addressed. So we came up with a new DRS algorithm, and that new DRS algorithm is completely different than the one we used before. We don't call it DRS 2.0, we call it vSphere 7 DRS. And due to the complete redesign, you will notice there's a different behavior on a day-to-day basis. DRS is not looking at active CPU and memory anymore. And now it's more a combination of CPU demand, memory granted, swap balloon, and network transmit and receive. What also changed is that DRS compares the host efficiency with regards to the behavior of the virtual machine. And due to this change, the migration threshold, the slider in the cluster settings, has a new function. DRS used to run every 5 minutes, every 300 seconds. We reduced that to every 60 seconds, allowing it to respond quicker to changes because of what can happen with these containers. And one of the biggest change of this 60 seconds is that it can trigger vMotions. So now you will see a more stable stream of vMotions in your cluster instead of every 5 minutes a few vMotions. And the last options, which I'm really proud of, is Duncan and I came up with this concept many years ago, and it finally was introduced in the product. And that is, we allow resource pools to be transformed into sort of quality of service buckets. And I will address that point later on. So let's take a look at the migration threshold. In the old DRS, we looked at the host load, and we compared each host load inside the cluster with each other. And then the threshold, the migration threshold, actually provided this guidance on how much difference of host load there could be within the cluster. But now there is no host load anymore because we're looking at the efficiency of a host with regards to the behavior of a VM. So the threshold had to change. Now it still acts as this metaphorical gas pedal, meaning that if you want to speed up with the car, you mash the gas pedal. Same thing with the migration threshold. If you slide it to the right, you will see more vMotions because it becomes more aggressive. Now in 7, this slider affects the preferred headroom, which is a soft target. And it uses different load averages based on the slider aggressiveness. Go to the right, you move it from 40 minutes all the way up to 10 or even 5 minutes. So the actual averages are smaller, and so you will see more peaks and you can respond to more peaks, right? So let's take a closer look to that headroom specifically. So you have five settings. 1, 2, 3, 4, 5. 5 is the most right one. 1 is the left one. If you slide it all the way to the left, you have no load balancing operations. There are still migrations happening, but those are for mandatory moves and are for things like affinity constraints. If you move a virtual machine to a host where it should belong because there's not a virtual machine, DRS will move it, but there's no load balancing. So the real load balancing starts at option 2. Now, if you select option 2, what we say is we allow a host to have 70% host load. Underneath that 70% host load, we think this host is acting great, and we don't bother with that host for moving virtual machines out. Now, if you slide it to the middle or you keep the default, that headroom now is 50%. So when the host load is exceeding that 50%, then DRS will start to think about, can I find another place for a particular virtual machine who is not that happy? If you slide it to 4 and 5, it becomes more aggressive, and then we'll say this host will start to what we call incur cost. This host is not as efficient as we thought it was. That happens at 30%. So if the host load exceeds 30%, that host is considered to be costly. So maybe another host will have a better location for a particular virtual machine. So if you look at the algorithm, this is a simple overview of the DRS algorithm. We take the slider into effect for CPU, memory, and network, right? Let me see, where do I begin? So what we do in the UI is we show a DRS score of each virtual machine and cluster. And this is done on the measurement of these 3 elements, CPU, memory, and network. Now, if a host is overcommitted, DRS uses the entitlement of the virtual machine itself. Now, entitlement is being calculated every 5 minutes. So this provides an accurate short-term behavior. Sorry, my power went off. The migration threshold determines that soft target headroom, what I discussed. So let's say the host is now 60% loaded, and you have set it to a conservative setting. You set it to 2. That means it's below the 70%, and thus the score of that host is 100% because it's still not surpassing that threshold. Now, if the combined VM demand is higher than that threshold, so let's say it's 80% instead of 70%, then we calculate a particular cost. And we do this to determine the best host in the cluster for that particular workload. We do this for CPU and we do this for memory, but we cannot do this for network because there is no overcommitment in network technology. So we look at the demand and we look at the congestion threshold, which is set to 67%, which is an advanced setting. The combined CPU efficiency, memory, and network score creates this DRS score. And that is a score that's being calculated for every virtual machine with the combination of every host. And so we do this for every virtual machine, every combination possible. And the best score will trigger a migration threshold if it's better than the score of the virtual machine running on the source host. Let's talk about scalable shares. Now, this turns resource pools into the quality of service groups. Now, this diagram shows a default behavior of resource pools, and resource pools get their resources based on the relative priority of the construct itself, but they do not take those child objects, those virtual machines, into consideration. Now, in this scenario, the cluster has 100 gigabytes and 100 gigahertz, and the ratio between those two resource pools are 2:1. Therefore, the high shares resource pools will get 2/3 of the 100 gigahertz at 66 gigahertz. It divides this amount across the siblings, the virtual machines, and as a result, if every virtual machine is active at the same time, they each get 11 gigahertz because they are configured the same. Now, the normal share resource pool get only 33 of the cluster resources, but it only has to divide it between those two VMs. So if those two virtual machines are active 100% of the time, they will get 16 gigahertz. Now, this behavior contradicts what most customers expect from what the shares should do. So we introduced scalable shares, allowing you to have like this QoS behavior. You can enable it at the cluster level and at the individual resource pool level. By enabling scalable shares, the resource pools take the actual share value of the virtual machines inside of it. When I talk about virtual machines, can also be pods, of course. Now, using the same scenario, those 6 virtual machines inside the high shares resource pools have a total of 12,000 shares of CPU. As there is a 2:1 ratio between those resource pools, the shares are doubled of the high shares resource pools, resulting in a share value of now 24,000 against the 4,000 shares of the normal shares resource pools. So you end up with a distribution of 86% for high shares and 40% of normal shares resource pools. Now, this calculation is done automatically. And that suits the dynamic nature of the modern application architecture with VMs and the high churn containers. So if an app scales out inside a resource pool, the resource pool value automatically gets recalculated, realigning its stake of those cluster resources. Now, in this half hour, I concentrated on the compute side of changes of vSphere 7, but there's a lot more of new stuff in 7. For example, lifecycle management, which Duncan is going to talk about in this session. Now, one thing that I want to end with is that overall vSphere 7 is a foundational building block for an infrastructure that is home for those new workloads, for containers, for VMs. And HCI is the foundational element for private and public clouds. Duncan will tell you more about HCI in his next session up next. Thank you all for your attention.
Hey, Frank, there was a question in the Q&A. I don't know if you managed to get to it from Wesley.
What is the overhead for his new DRS activity? Every 60 seconds will increase the consumption through the cluster. The overhead of the the algorithm itself is really low. We updated it and we made it very efficient. And because we have these new headrooms, we can actually start to think about only using a selective number of VMs to figure out whether a load balancing operation needs to occur. So if you have more than 256 virtual machines inside a cluster, we will only use a select number of virtual machines. We're not going to look at all those virtual machines again. So in essence, due to the new algorithm, it becomes much more efficient and the overhead is less. So the second question, is there a way of customer to obtain functionality of vSphere 7 with Kubernetes without VCF or without being TKG per core? As of now, we chose to use VCF as our launching platform for this new functionality, but we are working on different solutions. Unfortunately, that's the only way I can talk about it. So I cannot provide any more details. But thank you for your question.
And VMworld is very close, right? So keep an eye out for things that may be announced at VMworld. It's always
allegedly.
Indeed, indeed.
I think I saw that you've answered a lot. Wow, nice. Okay. Any more questions?
Frank, I have one for you, Andre here. It's not actually a question, it's more like an observation. I'm so glad to see what we do today with networking on DRS, right? I think we waited for a very long time looking at CPU and memory, and now it looks like we have a very strong offering that on DRS that also considers networking, right? So important for all these workloads, that especially containers, right? With all those sidecars and everything talking all the time.
Mm-hmm. Yeah, and so the thing is, it's still not done. It's still in its early stages, because with the network business unit introducing all these new capabilities, think about the different switches that we now have. We work closely together with the network business unit, NSBU in internal terms, to make it more efficient and make it better. Now, the reason why it took so long is actually due to the old algorithm. So the old algorithm, like I said, we looked at host load, but if you dive a little bit deeper, what we did is we calculated what's called a host load standard deviation. And we did this for both CPU and for memory. Now, when you are familiar with standard deviation, it's already difficult to compare two standard deviations on two different topics to each other, and then figure out how to weigh this. Because even if you have an answer, then you need to understand that, okay, maybe CPU is higher now than memory, but is this more important? So we need to take the overall cluster load into account as well. And then we need to figure out how to provide a particular weighing score to those standard deviations. Now, this is pretty complex. If you want to add a third one, network, that becomes almost impossible to use for a load balancing perspective. You can do this for initial placement because you can use hints, but for load balancing, which one is more important, right? And especially if you have three elements competing for each other, and even if they're really close. And another problem is that CPU and memory are so closely tied to each other, because if you spend sending a lot of packets, you typically consume a lot of CPU as well, right? So now you can get this skewed view of the world where you think that memory is not important, whereas there are just a couple of virtual machines pounding away at the network. So because we had that old algorithm, we couldn't really address that correctly. So what we did is that was one of the reasons we completely redid the algorithm, and we made this universal language where we can compare different elements such as CPU, such as memory, and network close to each other. Now, the cool part of this pluggable or this universal language is that it actually becomes pluggable. So one thing that we're looking into right now is, can we do this for PMEM as well? Can we do this for GPUs as well? Can we do this actually for NUMA as well? And all these things are now researched to figure out how can we plug this in that customers can use this. Now, what I'm saying right now, this is future work. This is not going to appear in the next update, of course, but these are the research topics that we are looking into.
Very cool, man. Thank you.
Okay. So can I please answer the question again? Is there a way for a customer to obtain the functionalities of vSphere 7 with Kubernetes without VCF? Now, as of now, this is the only way to go forward. You have to deploy VCF, but we are thinking about other ways of making it accessible for customers, but the details are still not finalized, and thus we cannot address this in detail. Now, one thing that Cormac said, which is obviously very interesting, is typically we announce new stuff at VMworld. So there is a chance that we will announce something around VMworld on this topic, but I'm not sure, and I'm not allowed to confirm anything. So I hope this helps a little bit.
Thanks, Frank. Can you close your deck so
Yep.
I can get started with mine?
Here you go.
Awesome, thanks. Thanks for this talk on cloud native workloads and what we're doing from that perspective. So just to give you an overview, in the upcoming 30 minutes or so, I will be discussing what we've introduced for hyperconverged technology, specifically in vSphere 7 and vSAN 7.0. And then after that, Cormac will be discussing what we did for cloud native storage, which also leverages typically the vSAN capabilities that we've introduced. So what I will be talking about is very applicable to what Cormac will be discussing. Now, Frank already mentioned that all of these new types of technologies have been popping up over the last couple of years. And I think we've all seen that over the last couple of decades happening, right? We've introduced virtualization, then we introduced hyperconverged infrastructure technologies. We have things like stretched clusters, and of course there are containerized workloads as well that are starting to pop up. And those containerized workloads are starting to pop up at a massive rate. And if you compare that to what we have been doing over the last couple of decades, IDC has done some calculations, and the calculations that they've done shown us that in the upcoming 5 years, we will be deploying more applications and services than we have done in the past 40 years. Now, I've spoken to many customers over the past 6-7 years while I've been responsible for vSAN, and one thing is very clear, and that is that the work pressure for the majority of IT people is extremely high, and that's typically a result of the fact that business owners still see IT as a cost center, and preferably we should be running our IT solution as cheap as possible with the limited amount of people that we can potentially leverage. And that of course poses a lot of challenges for you as an IT administrator or as an architect, because you will need to take that into consideration when you start building the design for your next solution. Now, if you look at the majority of solutions that we have out there today, the problem that we have with traditional data centers is that they were never really designed for the types of workloads that you will be running or may already be running right now, but potentially will be running, or probably for sure will be running in the upcoming 5 years. A lot of these cloud native workloads will expect a different type of infrastructure to sit underneath. The current infrastructure is typically not only too complex, but it's also too inefficient, and most importantly, it's relatively slow compared to these newer types of infrastructures that have been emerging, hyperconverged infrastructure being one of them. And of course, if you take all of these different factors into account, complexity, inefficiency, and then the fact that it's slow as well, not only from a performance perspective, but also from an operational standpoint, that poses a large risk on you as a potential business owner, or potentially you even as an administrator or architect, because you're still responsible for running these newer types of services that they typically will want to have deployed in a relatively short amount of time against the minimum amount of cost as well. So that's where the risk factor comes into play. Now, of course, VMware has been building out capabilities over the past 7 or 8 years that allows you as a customer to start deploying these infrastructures, which are not only easier to manage, but also easier to deploy and hopefully easier to upgrade as well in the future. We started out with our core offering, being our core HCI offering, vSAN and vSphere. This is something that we released in 2013 as a beta, and customers have been using that in production for the past 6 or 7 years already. Now, not too long ago, a couple of years after that, we released vSAN. We also released a product set, which is called VMware Cloud Foundation. And this is the solution where we actually combine many of our different capabilities that we have available within VMware, but we actually release them as a full stack. This is what we refer to as our full stack HCI offering, and that is VMware Cloud Foundation. Now, for those who are not aware, VMware Cloud Foundation doesn't only contain vSAN plus vSphere, but it also includes NSX, and it also configures NSX for you end-to-end. And I think this is probably the most important part when it comes to HCI or when it comes to VMware Cloud Foundation. And that's the fact that it not only solves the operational aspects, but it also solves those day 1 and day 2 operational points. Now, last but not least, the one thing that I do want to mention, because I think it's relatively important to mention for customers, because not many customers are aware, we also have this hybrid cloud offering. I'm not going to talk about hybrid cloud specifically, because I do think we all understand what the value is of hybrid cloud itself. But I do think it's important to understand that the technology that we use in a lot of these hybrid cloud environments is also based on that full stack HCI offering that we have available for on-premises. So if you're running VCF on-premises, please be aware that solutions like VMware Cloud on AWS or Azure or Google Cloud Platform also leverage the VCF platform internally to run their cloud workloads on top on. So it's the exact same stack or a very similar stack that they are leveraging, that you are leveraging on premises as well. And this, in my opinion, ensures that not only are you capable of using it at your scale right now, but potentially also a massive scale in the future. Now, one of the things that enables this, and this is one of those slides that a lot of people tend to skip, is policy-based management. And policy-based management is not part of vSAN. It's also not part of VCF, but it actually comes as part of vSphere, and it's a feature that is included with vSphere itself. So what does policy-based management allow you to do? Now, for those who have never done anything with vSAN, or for those who haven't done anything with virtual volumes before, policy-based management basically allows you to specify within a policy how a particular workload should be deployed within your cluster. Meaning, from a storage perspective, you could, for instance, specify the level of RAID protection for a particular application. Or if an application needs to be striped across multiple disk groups, potentially multiple hosts, all of that you can specify within a policy. But on top of that, you can also specify, for instance, if you're using something like virtual volumes, if a particular workload needs to be protected with replication or needs to be snapshotted on a regular basis. All of that is possible through the power of policy-based management. And I think it's policy-based management which allowed VMware to become the market leader in the HCI space, because no one else is doing that at this particular point in time. And policy-based management is what allows you to manage and operate an environment very efficiently. Now, if you look at it from a vSAN perspective, just to give you an idea before we start looking into the new capabilities, from a vSAN point of view, when you look at a vSAN-based virtual machine, and you can see the screenshot here, it just looks like a bunch of files. However, when you start drilling down and you realize there's a policy associated with that particular file, in this particular case, a VMDK, so a virtual machine disk file, that VMDK has a policy associated with it, and within that policy, you can specify what the protection level should be. In this case, I specified that I would like to be able to tolerate a single failure, meaning one host can fail at any point in time, and my data will still be available. And as a result, you can see that we have 2 copies of the data in our environment available, and on top of that, we have a witness. And the witness is there just in case anything happens from a networking perspective, so the cluster can figure out who owns the data and take action based on that. Of course, we don't only have the file view. On top of that, we also have the component and the object level view. So from a vSAN standpoint, you can even see where the data is being stored on which particular host, which caching disk is being used, and which capacity disk is being used. So all of that information, of course, is available within the UI. Not only do we have that option available within the UI, but we also provide you the ability to specify within the UI what your data center looks like. And I think this is something that is truly unique for the HCI offering that VMware has compared to all of the other solutions out there. If you have a data center that looks something like this, so you have multiple racks, they don't necessarily, of course, all need to be filled up and as neatly cabled as this one. But if you have an environment that looks like this, you can also specify for vSAN specifically what your environment looks like. So you can mention that the first 2 hosts are part of the first rack, 2 other hosts are part of the second rack, and then we have a 3rd rack as well. Now, if you would go back a slide and you remember the diagram that we had where we had those 3 components for a particular virtual disk, you can imagine that when we specify these particular fault domains, we can now ensure, or vSAN can ensure, that the data is spread out across those 3 different fault domains. So even if 2 hosts would fail simultaneously and they are part of the same rack, because of a PDU failure or whatever it ends up being, your data would still be available because vSAN has taken care of the availability aspect from a data center point of view. Now, talking about data centers, even if you would have an environment where you would have multiple data centers, we also have the capability in the UI to specify where your hosts sit in which particular data center. So if you specified which hosts are part of which data center, and you've also specified where the witness resides within your campus cluster, this needs to be within 5 milliseconds round trip latency in order for it to be supported. But as soon as you've done that, vSAN will take care of the placement of the data across those data centers as well. So not only can it take care of placement within a data center across racks, it can also take care of placements across the data centers on top of that. Now, of course, if you have a virtual machine that does not need to be spread across multiple locations, you can also specify that within a policy. All of these different capabilities you can configure through policy, and that is the great thing. If during the lifetime of a particular application, the requirements of that application changes, you don't need to move the virtual machine from one data store to the other data store. You simply change that storage policy-based management policy that was associated with it. So by changing the policy, the placement of that virtual machine and the objects, the disks, the data will be spread out across the data center, depending on how you've specified within the policy. So that is the great thing about this particular solution. And then last but not least, before we start looking into vSAN 7.0, there are a couple of capabilities which I think are underappreciated, but are very, very valuable. And the first one, and probably the most important one, is Skyline Health. This used to be called the health check, the vSAN health check. And what it basically does is it informs you about the current state of your vSAN cluster. So it will tell you if, for instance, you're running with an incorrect driver or with an unsupported level of firmware, or if the latency of a particular network connection is going above a particular threshold, or for instance, if a disk has failed. So all of those different types of health checks are part of the Skyline Health configuration, and it will provide you all of that additional information about what your environment is doing. Now, of course, from a performance perspective, we also have a lot of information available in our UI, not only what we are doing from an I/O perspective, but also what is happening from a latency perspective, both from a disk group as well as disk perspective, but also, of course, also from a virtual machine point of view. So if you're troubleshooting a particular application, you can also look at a particular virtual machine and start drilling down into what that virtual machine is doing. And then last but not least, of course, we also provide a great capacity overview, which informs you about what your environment is doing from a capacity perspective, what kind of data is being stored. Now, if you look at the recent release that we've had, and hopefully some of you have already seen this, but if you haven't, there were 3 main keys in the vSAN and vSphere 7.0 release. First of all, lifecycle management. Now, the lifecycle management aspect, I'm going to be discussing that a bit more in depth in a second. This applies to every single customer out there, whether you're a vSAN customer or a vSphere customer. So it applies to all customers out there. The native file services is a feature that is purely intended for vSAN customers. So it is something that you can enable on a vSAN level. I have a couple of demos in my presentation as well that I will show you that will give you an idea of how that actually works. And then last but not least, the enhancements from a cloud native storage perspective are the capabilities that Cormac is going to be discussing in his 30-minute section of today's event. Now, vSphere Lifecycle Manager is one of those features which I truly believe a lot of customers will start appreciating as soon as they start using it. The majority of you have probably used Update Manager in some shape or form over the past 10, 12 years. I think it's fair to say that Update Manager was a great solution. However, the big challenge with Update Manager was that it wasn't really intended to be used the way that customers are using it today. A lot of customers have told us that what they would expect from an update management tool is that it should be managing clusters and not individual hosts. Update Manager was designed to update individual hosts and not really perceive that single cluster as a management object. And that is exactly where Lifecycle Manager comes into play. Lifecycle Manager is a solution that is intended to not only manage hosts, but do that at a cluster level. So you can define at a cluster level what the desired state of your environment should be, which vSphere version it should be running, which drivers it should be running. And if you have the Dell or HPE firmware plugins running, of course, you can also define which firmware versions your particular cluster should be running at. Now, the great thing here is that if any form of drift is experienced, with drift meaning there's a difference between what you specified within the image and any given host, vSphere Lifecycle Manager will now go out to that host and do the update required. That could be a vSphere update, could be a driver update, but of course could also be a firmware update. Having said that, keep in mind that when you do a firmware update using Lifecycle Manager will actually make a call to either the Dell or the HPE plugin, and the Dell or the HPE plugin will actually execute that particular firmware upgrade. Now, there's a couple of things which I think are important to understand. And when you're looking to deploy or start leveraging vSphere Lifecycle Manager, all of the hosts within your cluster need to be running ESXi 7. Of course, your vCenter server also needs to run vSphere 7, or needs to be vCenter server 7. On top of that, every single host in the cluster needs to belong to the same vendor. Now, it's not something that we see often, but we do have a couple of customers that actually run a mixed configuration, not just from a host type point of view, but even from a host vendor standpoint. So hopefully you're not one of those customers, because if you are, you can't use vSphere Lifecycle Manager at that particular point in time. The other thing that I do want to mention is that stateless configurations are not supported with vSphere Lifecycle Manager today. So if you're using stateless configurations, you can't use Lifecycle Manager as is right now, but hopefully that is something that will change over time. Now, one of the features which I think is probably a minor feature, but customers will value very much, is the fact that we've introduced a compatibility check for specific components as part of vSphere Lifecycle Manager as well. So if you're a vSAN customer, you probably are aware of the fact that we only support specific disk controllers, and that's for a very good reason, because these disk controllers were tested end-to-end with vSAN. Lifecycle Manager has the ability to actually validate those components as well, to ensure that they are capable of not only supported for vSphere, but also supported for vSAN. Of course, in the future, we will probably be extending this. So potentially you can imagine that in the future, we will do this for network controllers, potentially disk devices, and basically anything else that would be part of our HCL. But today it's only limited to storage I/O controllers. Now, for those who haven't seen this, this is a feature that wasn't part of a product itself, but it's a feature that is part of the VMware Compatibility Guide. And I'm only mentioning it because I know not many customers are aware of this capability. But when you're one of those vSAN customers that actually finds himself going or herself going back to the VMware compatibility guide on a regular basis, what you can actually do today is you can subscribe to particular components, not only to disk controllers or to disks, but you can also subscribe to a ready node configuration. So what does this mean, subscribing to a component? Well, as soon as you've subscribed to a particular component, as soon as anything changes from a supportability standpoint, so whether there are new drivers, a new firmware version, or a new version or an old version of vSphere is certified against a particular component that you've subscribed to, you will now receive an email with the changes that were implemented. So it will allow you to go back to your environment and actually validate or verify if you need to make changes to your environment as well, as soon as you've subscribed to the VCG. Now, before we go to the next section, there's a question that came up if we see additional brands being supported for vSphere Lifecycle Manager. And of course, this is definitely something that we are looking into. I can't mention any particular dates or vendors that we are working with, but we're working with multiple vendors to ensure that we can start supporting their solution in the future as well. Now, one of the things that I would like to ask you as customers is to ask your vendors, if they are not HP or Dell, to start supporting these efforts, because some of the vendors may not have it at the highest level of priority, because there is an aspect for those vendors as well that they will need to do from a development standpoint. So if you're not a Dell or HPE customer, make sure to provide the feedback to the OEM and ask them to start developing this capability. Now, I've already mentioned it. As part of vSAN 7.0, we released a feature called vSAN File Services. vSAN File Services basically allows you to create file shares leveraging or running on top of vSAN itself. These file shares can be NFS version 4.1 or NFS version 3. We're not supporting any of the other file service protocols just yet, but of course, this is something that we will be exploring in the future. Now, I have a couple of demos that will actually show you what it will look like and what kind of functionality you will have available as soon as you enable these file shares. So one of those things, of course, being quotas. You can specify a threshold or a hard quota as well for a particular file share. Now, the great thing about this particular solution, in my opinion, is the fact that it is fully integrated both with vSAN as well as with vSphere. So it's part of the exact same user interface. Now, if you look at it from an architectural perspective, just so you get a better understanding of how it has been implemented, if you look at it from the top down, and we have an NFS client, so this could be a Windows machine or a Linux machine that likes to connect to an NFS share, typically what you will need to have running is an NFS server. Now, of course, this NFS server needs to be running on top of something as well, and this is where the vSphere environment comes into play with both vSAN as well as the vSAN virtual distributed file system. Now, when we run a VDFS on top of vSAN itself, we still need to run those NFS servers somewhere. And these NFS servers will actually end up running not only in a virtual machine, but they are part of a container stack that runs within that virtual machine. Now, before anyone asks the question, these virtual machines are automatically being deployed by vSAN itself. Its ESX agent manager actually deploys the virtual machines for you, and vSAN is responsible for managing and upgrading and updating those virtual machines as well. The other cool thing about this solution is, before anyone asks a question about efficiency, is the fact that if you look closely at the diagram, it actually says vSocket and vMCI in the middle. This is a PCIe interface within the virtual machine that allows the container to directly communicate with the kernel modules, so directly communicate with the vSAN kernel modules. And this is one of the reasons it's highly efficient. Now, when you create a file share and you associate a policy with it, and that policy could, for instance, specify it needs to be a RAID 1 configuration or a RAID 5 configuration, vSAN will then take care of all of the data objects that will need to be deployed underneath. So vSAN takes care of the bottom half of the diagram, while VDFS, the vSAN virtual distributed file system, takes care of the upper half of the diagram itself. Now, as I mentioned, we will see these virtual machines being deployed. Within these virtual machines, you will have these containers running. We will only have at most 8 active containers running at any given time with this particular version. But if you have 32 hosts within a cluster, you will see 32 virtual machines being deployed. And these containers can actually move from one host to the other host, depending on what is happening in your environment. As mentioned, ESX Agent Manager is actually managing those virtual machines. So from that point of view, you as an administrator don't need to manage these entities any longer. The other thing that I do want to mention is that from an availability perspective, when a failure occurs in your environment, so as you can see, one of the hosts has gone down in this particular case, and as a result, one of those vSAN file services VMs has been impacted, it doesn't necessarily mean that your file services offering itself is impacted as well. Because as I mentioned, we are running these containers within each of these virtual machines, and these containers can actually run on top of the same host. So they can run on top or within the same virtual machine. So you could have 2 virtual machines or 1 virtual machine running 2 containers. And that is actually what takes care of the availability aspect of things. A couple of things to consider. I'm not going to read all of these out, but there are 2 things which I think are very important. If you would like to use vSphere Lifecycle Manager in combination with vSAN file services, you need to run at least vCenter 700A. That is the first version that we support the combination of those 2. The other thing that I do want to mention is stretch clustering and 2-node configurations are explicitly not supported for vSAN file services today. Before anyone asks, of course, this is something that we will be exploring in the future. Now let's start looking at the demo before I start answering some of the additional questions that just came in. In this particular case, we've already configured vSAN itself, and we have a 3-node cluster. And what we're going to do is we're going to enable vSAN file services. So I'm going to go to the vSAN section, click on Enable, and then I will need to start filling out additional details. As you can see, I will need to click Trust the Certificate, and then what's going to happen is that an OVF is going to be downloaded to my environment, which will deploy those virtual machines. If your vCenter is not connected, you can actually manually download the OVF as well and upload it to the interface. Then we will need to fill out our namespace, the file services domain. We will need to specify the DNS server and the DNS suffix. Now, of course, the next thing that we will need to do is we will need to start specifying the networking details for our containers, because the containers are actually what will be connected to the network. The containers will be receiving those IP addresses that we will be specifying in the next screen. Of course, the VMs that are hosting these containers will be connected to this virtual machine network. Now, we can do a couple of things. I can type out all of the IP addresses manually, but I can also fill out a single IP address and then click autofill and click lookup DNS. As soon as I click on autofill, what will happen is that the UI will actually assume that they can append the IP address with 1. So 210, 211, 212. And on top of that, we'll then do a lookup DNS, and the DNS names will also be entered. Now, after that, we can simply click next, finish, and vSAN file services is going to be enabled. Now, about a week ago or 2 weeks ago, I had a question from someone who went through the same exercise, and they asked me, they said, I deployed vSAN file service in my environment, but I didn't see that ESX agents resource pool popping up. Now, the reason he did not see the ESX agents resource pool popping up was because of the fact that he did not have DRS enabled. We can only create the resource pool when you have DRS enabled. If you don't have DRS enabled, you will simply see these file services virtual machines under the root of the cluster itself. It will still work as expected. So from that point of view, it's not a problem at all. So we've deployed the virtual machines. Now the containers are going to be spun up within those virtual machines, and then file services will become available. So I can simply click on the file service interface. I can see all of the details that we've specified. Of course, now that we've enabled file shares, we've also would like to start creating those file shares itself. So as soon as we've enabled file services, you will see a new option popping up in the interface called File Server Shares, and we have an option to add file shares in this particular interface. We can provide a name. and we can select a policy. So this policy could be RAID 1 configured, RAID 5 configured, RAID 6, or whatever you would like to use. Then we will need to specify, or well, we can specify what the warning threshold should be and what the quota should be. So the hard quota for this particular file share. And then we can specify which IP address can get access to this particular file share. I saw a question popping up around potential Windows Active Directory integration. We don't have that available today, but of course we are exploring that as well for a future release. So that is definitely something that we are considering. So now that we've created the file share is going to pop up in the interface, and we can select the file share as soon as that has popped up. And then what we can do is we can copy the URL to that file share and give it to the person that needs to connect to this particular file share. One of the other things that we've added to the interface itself, because it's not just about creating file shares or enabling file services, it's also about managing these systems. So we also made sure, for instance, that from a health check perspective, we added additional health checks that actually shows you what the environment is doing and if it's healthy from a file services standpoint. Of course, the other thing that we've added is additional information around the capacity that is being consumed in your environment. So if you've created a next number of file shares, the interface will now also start showing you how much capacity is being consumed by those file shares, or potentially by those containers that are consuming those file shares. And that is something that Cormac is going to be discussing in the next part, the container aspect of things. Now, last but not least, before I'm going to answer the remaining questions that are in the chat and hand it over to Cormac, is what these things actually look like in the UI. Because we have these objects in the UI, but of course, we don't only have file shares in the UI, we also have virtual machines that are part of the UI as well. Now, as you can see, we have two file shares and we have a container volume here. When we go to monitor and we look at the virtual objects, we will actually see a large number of objects. And this is because we also have a significant number of virtual machines. And actually it's only a handful of virtual machines at this point in time. Now, the great thing about the UI is that you can filter for particular objects. So I could say I would only like to see the file shares, or I would like to see the file shares and my container volumes. As soon as I've selected those options, I can now select one of those file shares or potentially my container volume, and I can start inspecting that object. So I can, for instance, see which hosts are being used for this file share, which disks are they being stored on, or which caching disk is associated with my file share. On top of that, in the UI, I can also see what the unique identifier is. If you're one of those customers or one of the community members that would like to script something, you can use the UUID to retrieve more information about the file share itself. In this particular case, I'm showing RVC, which is our Ruby vSphere console, but of course you can also use something like Power CLI. Of course, that's not where it's going to end. I'm not going to be discussing our roadmap in depth, but I do want to make sure that people understand that we have an extensive roadmap, not only for on-premises, but also for edge deployments and public cloud deployments. Of course, in the future, we are planning to provide you more insights around what kind of data is being stored. And I noticed there was a question around data analytics as well. And of course, that is something that we are exploring. We would like to provide you more information around what kind of data is being stored, not only on your file shares, but potentially within those VMDKs that are being stored as a block object as well in your environment. And of course, with the acquisition of Datrim, which has recently happened, we will be providing extensive data protection services on top of that. And then last but not least, we all realize that there's a massive shift happening in the industry where customers are moving from traditional applications towards cloud native applications. And this typically also means that other types of storage services are required. One of the questions that I saw popping up was around the fact whether we would be potentially introducing an S3 interface. And of course, these are all of the different things that we will be considering for deploying on top of vSAN as well. As you can imagine, when you're capable of deploying something like file services, NFS v1 and or 4.1 and NFS v3, we should also be capable of deploying S3 capabilities on top of vSAN. With that, we've reached the end of my session. I realize there's a couple of questions left, so I will answer the questions in the Q&A first, and then I will ask my lovely assistant, Cormac, if there are any questions in the chat that I should still answer. The first question is around file services replication at a share level, and if there is any chance of downgrading the Nest functionality due to advanced licensing. From a licensing standpoint, I'm not really sure. I know it's part of enterprise today. What's going to happen from a licensing standpoint is typically decided by a completely different team in our business unit. I'm happy to provide them the feedback, but I can't speculate on what's going to happen from that point of view in the future. From a replication point of view, we don't have the ability for regular file services shares right now to replicate those as is. But of course, depending on the use case, we do have solutions around that. Cormac is going to be discussing the cloud native use case. And for instance, Valero does provide you the ability to actually back up and replicate the workloads that are running on top of those file shares. So we do have those capabilities for sure. The other question that came in from Manuel is vSAN file share. Can it leverage storage efficiencies like deduplication and compression? And yes, that is something that we do fully support. So you can enable deduplication and compression on top of your vSAN cluster. So it's enabled on a cluster level. You don't enable it on a per file share level. You enable it on the cluster level. But as soon as you have enabled it, or as soon as you have it enabled on a cluster level, you can now benefit from that functionality as well. So it's definitely something that we are catering for, and is something that would normally work in these types of environments. Now, one of the things that I mentioned is, for instance, stretch clustering, and someone is probably going to ask the question. It is something that is explicitly not supported today, but of course, that is also something that we will explore. So all of the capabilities that are available through policy are capabilities that either are supported or potentially will be supported in the near future. So that is definitely something that we will be targeting to solve in the near future as well. Cormac, were there any particular questions that I should be looking into in the chat?
Yeah, there was a lot of good feedback on this part of the session, Duncan. I'm already asked, a lot of these were feature requests, but really around analytics and how we can, how an administrator could actually manage the file shares, things like how many files do users have, and the file types and most access. So that's all good stuff, and we'll take that back to the product team and share that with them. There was a question about data locality. I don't know if you want to address that. It's probably outside the scope of file shares, but data locality in general on vSAN. I think we haven't changed our stance, if I remember correctly, that it's still true an RPQ, right? A special request.
So it depends on what is being referred to in terms of data locality.
Okay, I took it as having the compute and the storage on the same hosts. Maybe whoever posted that question originally, if they want to, just elaborate in the chat or in the Q&A.
Was it in the Q&A or was it?
It was in the Q&A, yes.
Let me see if I can find the question and read it out loud. So, let me close down my deck so you can start sharing it, because
it was a question from Fernando. Sorry, I'm not.
Do you see the question? Can you read it out?
Yeah, will this new version of vSAN be ensuring data locality to the VMs?
So I'm guessing that is a question that is asked because of the functionality that Nutanix has from a data locality perspective. So I think it's a good question. And if you look at the way that we've implemented things from a vSAN standpoint, so we took a different approach, or maybe the question may be different. So let me answer this one first before I answer the second one. Right. From a vSAN standpoint, typically there is no data locality, so the VMs are not running on the same host as where the data are being stored. The key reason for it being is fairly straightforward. First of all, data will always need to be replicated to 2 or more hosts from an availability standpoint, which means that writes will always need to go across the network, and those writes will need to be acknowledged from both destinations before we can actually acknowledge it to the virtual machine itself. So that's why there is no true benefit for us to provide data locality from that point of view, because we will need to have that right across the network regardless. The other thing that we've done is we've done some calculations back in the days when we started designing a vSAN, and we looked at the cost of moving data around to align it with the virtual machine itself. And then we looked at the latency that was introduced by the network. Now, if you look at 10 gig networks, and I think it's, you know, even more true today with 25 gig, 40 gig, and 50 gig, and even customers going towards 100 gig networks, the latency is extremely low. If you compare that to the cost of moving data from one host to the other, it becomes basically too expensive to move the data around to achieve data locality compared to the benefit that you could potentially reap from having the data locally. Now, the other thing that Cormac mentioned is we have a capability available within vSAN today. If there are any customers that run a database, something like Cassandra, for instance, that has its own replication mechanism, where it makes no sense for vSAN to replicate the data, we do have data locality where we can actually align the object itself, so the data of that VM, with the VM from a compute perspective. Because if you look at that architecture from an application standpoint, the application itself is replicating all of the data across the network. So vSAN doesn't need to take care of that. So we do have that ability within our offering. The other thing I do want to mention is when it comes to vSAN, we also have a memory cache. So the memory cache is for reads itself. So we do have some form of data locality, but that is purely for reads. So we have a small memory read cache on every single host where the VM is running. So the most recent reads for every single VM are going to be stored within that memory read cache. So we do have some form of locality from that standpoint, but it's implemented in a different way for various reasons. With that, I think we reached the end of my part. I'm going to hand it over to Cormac, and Cormac is going to be discussing the cloud native storage aspect of things. Cormac?
Thank you, Duncan. Just share my screen. Excellent. So we've heard an awful lot so far about what we're doing from a Kubernetes perspective, what we're doing from a HCI perspective. What I'm going to do now is I'm going to, again, focus in on Kubernetes, but really look at 2 areas that we're doing an awful lot of development work these days. One is in the area of cloud native storage, and that is essentially allowing Kubernetes to run on top of vSphere while consuming vSphere storage. I'll talk to you about why that is important in a few moments. The other thing, and Frank mentioned this in the opening part of this VMUG, is the fact that we have used VMware Cloud Foundation, or VCF, as the launch vehicle for vSphere with Kubernetes, which has now been called vSphere with Tanzu. So we've changed the name yet again. So I'm going to spend a little bit of time explaining to you why we have used VCF as the launch vehicle, and what are the benefits of using VCF, and indeed what are the various parts that are involved in standing up vSphere with Tanzu on top of VMware Cloud Foundation. Now, I'm going to probably say vSphere with Kubernetes a whole bunch of times in this presentation, because that's what I've been saying for the last 3 or 4 months. But when I say vSphere with Kubernetes, it's actually vSphere with Tanzu, I think, is the new name. So bear with me. So I know not everybody is familiar with Kubernetes, so I'm going to spend a little bit of time at the very beginning just talking about the relationship between Kubernetes and Kubernetes storage and vSphere storage, and how there's a mapping between the two and what that means, and so on. Now, why is it important? Well, there was this myth or assumption a number of years back that containers were just for stateless applications. In other words, you deployed a bunch of containers, you did some units of work, you got the result of that work, and then you threw it all away and you started all over again. There was no need to persist anything. Well, that's clearly not the case. And it became quickly apparent that that was not the case. And if we look at this survey, now it's a little bit dated. I think it might be about 2 years old, but it's done by a company called Datadog, who do all sorts of monitoring and so on. And what they revealed was that 7 of the top 10 containerized or Dockerized applications actually required some sort of persistent storage. So you can see there's a lot of key value stores and databases and so on that are now containerized. And so our customers came to us quite a few years ago and said, look, we want to do containers. We want to do it on top of vSphere. We require persistent storage. What can VMware do for us? And that was the beginning of the Project Hatchway initiative that Frank talked about, to provide a driver for both Docker and Kubernetes so that these frameworks could consume vSphere storage. Now, the Project Hatchway has morphed into what is now the CSI driver, the Container Storage Interface driver, which is a standard across all across all vendors who have some sort of plugin to Kubernetes. So for instance, OpenShift from Red Hat, they would have a CSI driver, and whoever else, Rancher, would have their own one, and so on and so forth. But we have our own one now as well for consuming persistent storage when Kubernetes is running on top of vSphere. So let's talk a little bit about the workflow that goes on when Kubernetes is running on top of vSphere, but it wants some persistent storage from vSphere storage. So Frank sort of ran through some of this as well about the various Kubernetes workers, and each of these Kubernetes workers has a kubelet installed. You can think of it as the Kubernetes agent. So these are just a set of VMs. And so then there is a request from your developer that says, I want to create what is known as a persistent volume. So the persistent volume request, persistent volume is actually nothing more than a VMDK when it's instantiated on vSphere storage. So this comes in, and I'll talk a little bit about policy-based management later on as well. Duncan did a little talk about that too. But policy-based management plays a significant role when you're deploying Kubernetes persistent volumes on top of vSphere storage as well. But at the end of the day, this persistent volume is just a VMDK. Now, you can set up Kubernetes in a number of ways. You could have the VMDK directly attached to a worker and then instantiate the container that's going to use the persistent volume, or you could instantiate the container in the first place and then have the VMDK attached to the worker. It doesn't really matter which way around you can do it, both are available. But in this particular case, we're just going to attach this VMDK to what is just a virtual machine, but it is part of the Kubernetes cluster. And then our pod, or to use Kubernetes speak, it's a pod, but a pod we can say is just a container. It could be more than one container, but to make things simple, let's just say a pod and container are the one thing in this particular case. And then the final step is for the kubelet to mount the volume up into, well, first to format it and then to mount the volume up into the pod. So now your pod or your containers running in the pod have access to this persistent storage. And so this is the workflow of the driver. So anyone who is creating these CSI drivers and Kubernetes, this is similar to the sort of one of the workflows, at least, to make a persistent volume available to a pod in Kubernetes. Okay. So we talked about a few things there. The first thing we talked about was the persistent volume. And just to reiterate, that's nothing more than a VMDK. So when we're talking about Kubernetes persistent volumes and Kubernetes is running on vSphere, then that persistent volume is just a VMDK and it's sitting on top of some vSphere storage somewhere. Now, the point is that we could create these persistent volumes statically, so manually. So if you wanted to, you could go into the ESXCLI command line and do vmkfs tools, but you really probably don't want to be doing this for every Kubernetes persistent volume. Fortunately, there is a way to dynamically create them as well. So this means that there is just a request for the volume and the VMDK is automatically created. So this is done through what's known as a persistent volume claim. Now, as you start getting into Kubernetes, which I suspect a lot of you will in the very near future, you'll find that these YAML files, YAML, yet another markup language, are used everywhere. And so here is a YAML file or a manifest file for a dynamic persistent volume claim. You can see what it's laid out like there. Everything in Kubernetes is a kind, it's a type of object. This is a persistent volume claim. And what we're going to do is we're going to request a VMDK to be created that is 5 GB in size. Now, the storage class name is interesting as well because the storage class, as you can imagine, provides a class of storage. And here we can integrate with storage policy-based management. So we can actually, when we look at the storage class manifest file next, we can actually specify a storage policy from vSphere that should be used when we create the persistent volume, aka we create the VMDK. So let's talk about the storage classes. And for us, a storage class when Kubernetes is run on top of vSphere is, as I said, a way of integrating with policies, with storage policies. And this becomes very useful for vSAN, extremely useful for vVols, but of course you could use it to tag VMFS and NFS volumes as well, so that you can decide where your placement of your persistent volume goes, where should it be instantiated. And this is just a very simple storage class, a manifest file. Again, it's YAML, like I said, and your storage class there, really the only things of interest are the provisioner, which is our CSI driver, and I mentioned that already, or driver from VMware for Kubernetes, and then the storage policy name, and that could be pretty much anything you want. It just reflects back to any of the storage policies that you have built on vSphere. So now when you think of Kubernetes storage, if you can think of a PV as being the same as a VMDK, as a PVC, as a request to dynamically create a PV, and then a storage class for dynamically creating a PV as well, but also referencing a storage policy, you already have a pretty good grasp of the fundamentals of Kubernetes storage already. Okay. So this is how we envision things happening. We envision there being multiple storage classes available that reference multiple different policies, all with different types of storage classes. Like bronze might be spinning disk, silver might be all flash, and gold could be even NVMe or something like that. So you can imagine that you have all these different storage classes that the administrator or vSphere administrator or DevOps person has created, and then you have the developer that comes along, and depending on the type of application and the storage needs of the application, they will actually create a persistent volume that references a particular storage class. And that is Kubernetes storage in a nutshell, to be perfectly honest. The one final point I want to take away is the dynamic nature of it. If you, again, you don't have to sit there creating individual VMDKs. I mean, you can if you really want to, but you don't have to, because there is a feature in Kubernetes, the PVC feature, to dynamically create the persistent volumes. Now, with that said, I've talked a little bit about the CSI driver already, the container storage interface. Like I said, everybody who is involved in Kubernetes today, certainly all the platform providers, they will contribute their own CSI driver, and they all adhere to a standard spec that is driven by the Kubernetes community. So we have just released the latest version of our CSI driver. When I say just released, we released it with vSphere 7.0, and we added a bunch of new enhancements to it. In no particular order, one of the things that Duncan mentioned in his session was the ability to have vSAN file services now available with vSAN 7.0. What that means for us when we're running Kubernetes on top of vSphere is that we can also create file shares as persistent volumes. So if we wanted a file share that would be shared, sorry, if we wanted a PV, a persistent volume, that was shared across multiple pods, we could create a file share on vSAN file services and present that resulting file share to multiple pods on our Kubernetes cluster. One of the other new things we introduced is support for vVols. So now we can build persistent volumes that are backed by virtual volumes. We have support for encryption, so we could encrypt individual persistent volumes through VM encryption. We can resize, meaning we can grow persistent volumes, and then there is CSI integration with vSphere with Kubernetes or vSphere with Tanzu, formerly known as Project Pacific. We have support for the Tanzu Kubernetes grid clusters. And also, if you are an enterprise PKS customer, which is now called Tanzu Kubernetes Grid Integrated, I believe, TKGI, we have support, a CSI driver support there now as well. So it's, as I said, it's starting to get a lot of traction, a lot of momentum, and we're adding new features with every release. Let's drill into these in a little bit more detail. Again, as Duncan said, file shares now available on vSAN, completely integrated. And again, if we wanted to have persistent volumes that were shareable between multiple Kubernetes pods, we can instantiate these, what are known as read, write, many persistent volumes. And these persistent volumes then can be accessed by multiple pods. They block volumes that were available originally and continue to be available today. These block volumes are what are known as read, write once, meaning that they cannot be shared between pods. They can only be accessed by a single pod. Again, all fully automated with file services. If there is a request for a read, write, many persistent volume, we will instantiate the creation of the file share, and the CSI driver will take care of mounting that file share into the pods that request it. So automated end-to-end, no manual action required. You don't even have to make the file shares. It is all done dynamically. So this is just a view of vVols. It doesn't really tell you an awful lot. What we have here is some of the visibility that we're able to bubble up using the cloud native storage feature that we have that complements the CSI driver. So we can show all sorts of information about a particular persistent volume in the vSphere UI. So you can see that this is a volume that is backed by a vVol data store. We can see what policy it is using. We can see whether it's healthy or not, and all of that good stuff. One thing to highlight is that vVol arrays today, they do offer a lot of features around replication, snapshot schedules, quality of service. They have a whole shooty match of various features. We are not in a position to leverage those in the 7.0 release. We can only support very simple vVols and not vVols that are utilizing array-based features. So just bear that in mind. It is a work in progress, and we'll probably be able to relax that in a future release. But in the 7.0 release and this initial 2.0 release of the CSI driver, it is just very simple virtual volumes to begin with. A little bit about encryption. It is a beta feature, but what it allows us to do is leverage a policy that includes VM encryption and encrypt individual VMDKs as persistent volumes. Now, the one caveat is that in order to mount a encrypted persistent volume to a Kubernetes node, that Kubernetes node must also be encrypted. So you do have to have an encrypted Kubernetes node. It's a VM, of course, and that needs to be encrypted before it can mount an encrypted volume. Now, the good thing is that you don't have to encrypt all of the Kubernetes worker nodes. You can just encrypt a subset of nodes, and then you just, through Kubernetes, you tell the Kubernetes API server that this particular persistent volume needs to be attached to this encrypted Kubernetes node, and then you're good to go. So there's various ways in Kubernetes to achieve that. I highlighted the node selector feature there. If you are familiar with Kubernetes, you probably know what that is, but it's just a way of selecting which worker node a particular pod should be attached to, or scheduled on. It's probably a better description. Great. This is a volume grow. It's another beta feature. At this time, what you need to do is you need to include in the storage class a particular directive, which is called allow volume expansion. You need to make sure that that is true, and then you can grow the volume. It is an offline grow at the moment, so you do have to do it offline. It is not available online. And what I mean by that is you have to unschedule the pod, grow the persistent volume, and then reschedule your pod once again once the volume has grown. Great, so that is an overview of Kubernetes features, storage features. It is also an overview of our CSI driver and what we do in CNS. I'm now going to get into VCF 4.0, VMware Cloud Foundation, which was the platform or the launch vehicle, release vehicle, whatever you want to call it, for vSphere with Tanzu, vSphere with Kubernetes. So just a little bit about what is VCF. There's probably two ways of looking at it, probably two ways you should look at it. There is what is known as the supervisor cluster. This is Kubernetes running on top of vSphere. It is a control plane made up of virtual machines, but your ESXi hosts become your Kubernetes worker nodes. So there we have the vSphere pod service. This is where we can instantiate pod VMs. Frank talked about those. We have the network service provided by NSXT. We have a registry service, which is where we can store all of our container images. This is provided by Harbor, if you're familiar with the Harbor product from VMware. And last but not least, the storage services provided by the CSI driver and the Cloud Native Storage CNS interface, or CNS feature that we just talked about previously. So all of those together go to make up the hybrid infrastructure services, which can be thought of as basically the supervisor cluster in vSphere with Tanzu. There is, of course, another service available here, and this is to give developers an upstream Kubernetes type experience. So if you're developers wanted to work at the supervisor cluster layer, they could, but it probably does not give them an upstream Kubernetes experience. If they want that experience, you have the ability to deploy the Tanzu Kubernetes grid clusters, which is very much an upstream like a Kubernetes distribution. So all of this together with VCF, and of course VCF is how we stand up our SDDC, our preferred way of standing up the software-defined data center. It has compute, storage, networking, and management monitoring all together. And we put all of that together into VMware Cloud Foundation, and now your developer has, as Frank mentioned, exposed Kubernetes API so that they can actually run or work on this whole environment through APIs. So again, reiterating, we have developer-like experience that can work not just on the infrastructure, but also on upstream Kubernetes. And you also have this native pod element as well that we talked about. And making Kubernetes run great on vSphere was another one of the goals that we had when we deployed, or when we looked to have vSphere with Tanzu on VCF, and we've achieved that now as well. So let's go through the deployment process, what's involved. There's essentially 9 steps in total. Majority of these would be done by the vSphere admin or IT operator, whatever terminology you want to use. And then at some point you would hand it off to your development team, and they would continue with whatever they needed to do in order to do development work. So step 1 here talks about creating a VI domain. If you're not familiar with VCF, there is a management domain, and then you have multiple workload domains. The management domain is where you put all your vCenter servers and NSXT components on, and so on and so forth. Prior to VCF 4.0.1, we could not deploy vSphere with Tanzu on the management domain. So you did have to stand up another workload domain in order to deploy it. But since 4.0.1, you can actually deploy vSphere with Tanzu on the management domain as well. So I'll talk about what that means in just a second. So this is kind of the workflow. Let's drill into the workflow in a bit more detail. As I said, there is the, if you were going to put this into production, you would more than likely or most likely create separate workload domains. Within those workload domains, they're full vSphere environments. There's a minimum of 3 hosts required, but we would recommend 4 for management and maintenance and all that kind of good stuff. You do need a specific license. You do require NSX T3.0, but like I said, as a VCF 4.0.1, you could also deploy a vSphere with Tanzu onto the management domain. But we're not going to do that here. We're going to set up a 3-node workload domain, and you can see it all there. This is all driven through the VCF SDDC manager. You can create all of this in the SDDC manager. So that's our workload domain. It has been configured. It has a cluster and everything inside in it. Now, one of the things that we do require is an NSXT edge cluster. This will provide north-south traffic. So things like load balancers and snatting and all that good stuff, but it also provides pod-to-pod communication within the supervisor cluster as well. Now, I have done this in the past for enterprise PKS, and it is quite a challenge when you consider all of the steps that are involved setting up an NSXT edge. What we have done in VCF 4 is that we've automated the deployment of NSXT edges. So you just fill in a wizard with IP addresses and VLANs and all that good stuff, and it is all taken care of for you. So the edge is stood up, and we automatically create a tier 0 and tier 1 router, logical routers as well. So that's that part done. So we have our infrastructure in place, we have our workload domain, we have our NSXT, we have our NSXT edge. We can now go ahead and enable vSphere with Tanzu. So what this does is it, remember that in vSphere with Tanzu, the ESXi hosts become our Kubernetes worker nodes. So what we do in that case is we install Kubernetes VIBs on each of those hosts, and that makes them workers. We also deploy a 3-node control plane. So this is 3 virtual machines that are deployed, and these make up the control plane for vSphere with Tanzu, that Kubernetes, and then the ESXi hosts are our worker nodes. Great, so now we have what is essentially the supervisor cluster set up. There are other things we can do. With a single click, we can deploy the Harbor registry, and this is where you can keep all of the Harbor, all of the container images for your developers to work with. It's very straightforward to turn that on. And then there's a content library. Why do we need a content library? The content library is synchronized to an external Tanzu repository, which provides you with the VM images for your guest clusters. So remember, we said that we can give developers an upstream Kubernetes experience. We can do that through deploying TKG, but the images for those TKG virtual machines, both the controller master nodes and the worker nodes, that come from an external repro. So we would set up that content library, and I'm not sure if you can see it there, but there's a subscription URL that you point to, and that gives you the latest and greatest TKG virtual machine images for creating the guest clusters. Now we will go ahead, and I think Frank talked about this as well, the ability to create namespaces. It's like a multi-tenancy concept that you can have in vSphere with Tanzu. And essentially with these different namespaces, you can define access rights and permissions. You can define things like what storage policies are available to the developers and all of that good stuff. It's a way of setting boundaries of resources for different developers who are sharing the same platform. So within the namespace creation, you get a namespace created, but you also get the NSXT networking configured to isolate that namespace from other namespaces as well. And again, it's very straightforward. It's just a couple of clicks, and then you can go ahead and do the resource limits, quotas, all of the stuff you would expect to do in a multi-tenancy type environment. At this point, you can hand it off to your developers now. We do provide a what you might call a web interface where the developers can download the various tools that they need to interface with their namespace. So they just log into their namespace and they have the tooling available, and then they can get on and start doing development work. And they can start developing within the supervisor cluster, so building pod VMs and so on, or they can very simply deploy a Tanzu Kubernetes Grid guest cluster for a more upstream Kubernetes experience. And these are the guest clusters. I think I've mentioned this a few times now. We get the images from the content library, which we already have synchronized. We can roll out just through a very simple manifest file, the YAML files we saw earlier, to build a TKG guest cluster. And these are just all the features of the TKG guest cluster. It really is like working with native upstream Kubernetes, but there are some engineering changes made by VMware to make it work better on vSphere. And it's, as I said, integrated with vSphere. It is fully supported by VMware. And again, it gives the developers that upstream Kubernetes experience. So we now have this concept of the supervisor cluster and what we refer to quite often as the guest cluster, which is the Tanzu Kubernetes Grid cluster. So you have two Kubernetes flavors now running here. And depending on what your developer wants to do, they can work in either context. Yeah, not really too much more to say about this. I think the main point is the visibility that the vSphere administrator now has to the development work that is going on and the resources that a developer is consuming. So what I sort of have there on the screenshot on the right is just various namespaces. You can see the supervisor control plane virtual machines. You can see the guest clusters, the GCO1, the GCO2, and you can see the virtual machines that are being used in those guest clusters for the control plane and for the workers as well. So a lot of visibility is provided. And deploying containers, obviously, once they have a guest cluster, it's just standard Kubernetes, so they can create pods and containers to their heart's content. Okay, the one final bit I wanted to talk about really is to do with the CSI driver, because there's a slightly different approach now when it comes to the CSI driver when we're dealing with vSphere with Tanzu. So again, we talked about the fact that we can have pod VMs, workloads running in the supervisor cluster. And here it becomes very straightforward because the CSI driver in the supervisor control plane can actually talk to vCenter server, which is where the CNS, the cloud native storage part is. And this is very straightforward because policies then are visible in the supervisor. We can build our storage classes from those policies, and any persistent volumes that we create in the supervisor, they're automatically instantiated as VMDKs in vSphere storage. So the request just travels out of the supervisor cluster straight into vCenter server. And we have visibility like this. We saw this start of screenshot before. You can see the cluster name. You can see the Kubernetes namespace. We can give you the PVC name. We can see labels. All of that good stuff is bubbled up in vSphere. Where it becomes a little bit more complicated, though, is when we're dealing with guest clusters. So now we have, again, the supervisor cluster. We have it in the namespace. In the namespace, we deploy a Tanzu Kubernetes Grid guest cluster. But this guest cluster cannot talk to vCenter. There is no path from the guest cluster networking to vCenter. So what we do in this case, when we deploy a workload, is that we have a paravirtual CSI driver, which is able to talk to the CSI driver in the supervisor. So any requests now to create volumes, again, we have the concept of policies, obviously, and storage classes. They're the same as before. So now when we make a request to instantiate persistent volumes in the guest cluster, that request travels from the PVCSI up to the CSI driver in the supervisor and then to CNS. And that instantiates our VMDKs as before. Now the visibility becomes very interesting. And what we've done is we've bubbled all of that information up into the vSphere client through CNS once again. And so you can see all sorts of information, such as the supervisor cluster, the namespace for the supervisor, the guest cluster, the namespace of the guest, and so on, the PVC name. All of that really useful information is bubbled all the way up. And so you, as a vSphere administrator, again, get full visibility into how a developer is consuming the underlying vSphere storage. So I'll just finish off again with an overview of all of the things that really we spoke to you about over the last hour and a half or 2 hours now. Frank talked to you about where we were going with vSphere, well, essentially where we're going with trying to create vSphere as a platform, not just for containers, but virtual machines as well. And so we talked then with Duncan, he talked about some of the new features that we've included in vSAN, file shares being a particular one. And then maybe I closed it off then with just giving you an overview of VCF and how VCF brings it all together and allows you to deploy vSphere with Tanzu and Tanzu Kubernetes as well. So again, reiterating the 3 goals of the vSphere 7.0 and the vSphere with Tanzu is to be able to give a developer this API-like experience so that they can, as easy as they would deploy applications in the cloud, be able to deploy applications just as easily on premises through the APIs that we have opened out for vSphere with Tanzu. Again, we had the pod VM. It's really all about making containers first-class citizens on vSphere. The pod VM achieves that. And then finally, if your developer does not want to work at that supervisor pod VM layer, but wants a more upstream Kubernetes experience, we also spent a lot of time making sure that Kubernetes as TKG guest clusters run great on vSphere as well. So I think that is all from me. I don't know if there were any questions. I will just have a quick look now.
Yeah, we've saved 2 for you, Cormac.
Oh, okay, great. The hard ones, right?
Yes.
Can I use persistent volumes with other container APIs like Rancher or OpenShift? No, you absolutely can. The CSI driver is vSphere specific. So as long as you're running Rancher or OpenShift or Antos or whatever Kubernetes distribution that you're going for, as long as they're running on top of vSphere, the CSI driver will be available there. So I did mention that there's now a CSI driver in the Enterprise PKS, but all of those other distributions that are running on top of vSphere, using vSphere as the platform, they can absolutely use the CSI driver as well. What I would say is that just check with the provider themselves and just make sure that your versioning and everything is right, because there might be a requirement on a vSphere version before they support it. In VCP, we used to put credentials as text inside in the Kubernetes host. How do we do it in this new version? We do it as a Kubernetes secret. So you build Kubernetes secrets to consumers in the CSI driver. And there's, I think it's up in GitHub, but there's the full documentation on how to deploy the CSI driver, and it actually shows you how to build those secrets as well. So, yeah. Cool. I think there was anything else?
No, nothing on the chat as well, so you got it.
Cool. Great. And I think we're almost right on time.
Yeah.
Excellent. So I'll just hand it over to you guys, maybe Anderson or Diego, whatever, if you want to, or Andre, if you want to close out the VMUG.
Yeah, I only want to thank you. I don't know if Anderson, Andre, but thank you guys. Thank you everyone that is watching us right now. I don't know if you guys already presented to Latam once or before. No, this is the first time, right?
First time for me, yeah.
That's
awesome.
an honor for us. It's the box idea, so yeah, so it's great. And I heard Pat Gelsinger in the other day on the radio, and he was saying that with all this social distancing, we are having opportunity to get closer than ever, right? So I think it's awesome. So thank you very much from all my heart to everyone here. And Anderson Gioli is with you.
Oh, it was great. I learned a ton. And I hope my friends on all the Latin America were able to extract whatever they can from you guys. And I hope to do this again somewhat in the future, maybe after VMware or next year, I don't know. Maybe make this a regular thing, like one time in a year, because we have so much interest on getting information from you guys. So I'm a fan, right? On my shelf here, I have books from you guys. So I'm biased, but it was really great. And I'm gonna switch to Portuguese a little bit. Galera, foi demais, muito obrigado mesmo, e espero que vocês tenham gostado de estar aqui com essas 3 lendas. E é isso.
Ok.
André?
Antes de você fechar, viu? Queria dar uma palavrinha.
Claro.
Eu falei isso porque eu achei que você estava fechando, né? Você ia falar, beleza, obrigado, até mais.
No, I wasn't closing, so now I'll switch to you, André. Go ahead.
No, that's fine, man. Look, just Diego mentioned something called radio. I heard Pat on the radio. It's not on your FM radio in São Paulo. It's actually radio is an internal innovation event at VMware. Right? That's what the radio he was mentioning about Pat Gassing and all that. I'll point one thing. Being an old timer like me, that were in 2007 showing vMotion to people, and people thought that was black magic, and then left the room and all that. It's so great to see that for many of the technologists here in the call today that invested time and effort in their careers into vSphere, that we actually upgraded the platform, right? Because you look around all the platforms people are trying to build nowadays, and they all want to build great load balancing like we have in vSphere, great resiliency, and many things that we have them production grade ready to go, right? Not only the compute, but for VMs, but containers and the networking side and the storage side. Look at how much vSAN advanced. I was here in Cormac, and like things we've been dreaming 10 years ago. Like nowadays, finally have that at a level that I would be comfortable allowing my mom to put their business over that. And they'll say, yeah, mom, that's okay. You can put business there, right? Because if it was 5 years ago, I might be like, mom, I don't know. Let's put that on a hardware that is different, and let's all sleep well tonight. But back on track here. Very happy to see that we basically upgraded vSphere that can actually produce a decent Kubernetes experience nowadays. Because if you try to deploy Kubernetes without being someone that lived in the communities that do that all the time, because you've been taking care of applications in a data center, it can be pretty hard, right? So I think that the experience it's for myself, for example, has been much better by using vSphere to do that. And I think we have Frank, Cormac, Duncan, Anderson, and Diego to thank, because it was a great presentation. And I really like that this is not marketecture. This is the actual real deal. That makes a lot of difference to me.
Thanks, everyone. And we're happy to do this again.
Awesome.
For sure.
I will get the opportunity. I'm going to switch to Português. Quinta-feira a gente vai ter o VMUG nível Brasil. Então, quem não se inscreveu, eu mandei o link aí para participar. So, this Tuesday, guys, we are going to have like the first VMUG for the entire Brazil with all the 6 local chapters. And we have Sanjay Puning coming to talk to us for 10 minutes. And we will have like Cameron Hyde to talk to the VMUG community here as well. So we have so much going on. It's great to have like 2 awesome events in 1 week. So I guess this is, we are past 2 minutes on our time. So it was great, guys. Thank you very much. Obrigado a todos. Gracias a todos.
Muchas gracias a todos.
Thanks, everyone.
Yeah.
Thanks, everyone.
Thank you.
Bye-bye.
Bye.
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 Ciao.